Okay.
And I'm going to kick off this month's Partner Spotlight. I'm Debbie Dennison with the Kentucky Workforce Innovation Board. Happy to see so many faces that are familiar and names that are familiar. And if you're just joining us for the first time, we have these spotlights monthly on the first Wednesday at noon Eastern Time. And we try to get that sent out so folks know what's upcoming. Today, we have exciting news, and we have an initiative that really started in the Somerset College and Technical Career area. And so today with us, we do have Eric Wooldridge. He's a professor down there with Somerset Community and Technical College. And he and Eldon Whitus is one of the instructors down there as well. They're going to be talking about some additive innovations and even what that means, because that's a term that may be new to some of us. But he's going to share what's been going on, what they currently have been doing, and then there's a teaser towards the end of the presentation for some things coming at the end of the month. So, Eric, without further ado, you guys introduce yourselves and share how this has all come to, come about, who's been supporting it, and all the great things going on with it.
Sounds good. I'll go ahead and switch to share. Can everyone see everything?
Yes, sir.
Excellent. All right. As mentioned, Eric Wooldridge and Eldon Whitus, we are of the Additive Manufacturing Center for KCTCS, Community and Technical College System. We are located in Somerset, and this is where all of kind of the 3D printing movement in Kentucky sort of had its genesis. And what we're going to talk to you today about is about what we have going on and what's about to happen and the technology itself. So this will have a couple of spots in the process for you all to ask questions, get a feel for the technology, and just start to imagine what your region, what your industry could potentially use it for. Just to give you the quick background, and I do like to start off this way, is to make sure that folks even understand what we're even talking about. So sometimes we will hear the term additive manufacturing and 3D printing. They are synonymous. And if you're not familiar with the concept, it boils down to this. If you take some material and you fuse it, melt it, pour it next to more material, and you repeat that process, you build up a part. It's in some ways, think of it as taking a glue gun and making a circle, and eventually that circle becomes a cylinder. That's how additive works. And what you're seeing on the screen is actually a metal printer that takes metal powder and then hits it with a laser, fuses that one layer, adds more metal powder, and does it again. So these are high-end pieces of technology, and they literally print 3D parts. And that's the power of the technology. The technology has been around for decades, but it didn't really become affordable, cost-effective, and available to everyone until about the 2013, 14, 15 era, which is when we started the Kentucky's kind of 3D printing program. And so just to get that process going, the technology now allows us to produce things that we could never produce before. So what you're seeing on the screen is actually a 3D printable part that looks like it's organic, that looks like it's made out of bone. And that's the real beauty of this particular technology. And it can be used in every industry you can imagine. In fact, we challenge folks to find an industry that the technology is not already being used in. So for example, the automotive industry uses it not only for actual car parts, but even tools and fixtures and jigs to help cars go together more efficiently. And why not? Because now the technology is so low cost, you can get a extremely powerful, precise machine that will 3D print whatever you have in mind for under $400. In some cases, $200. And we just can't speak enough about the complexity. Objects that we could never make before are totally possible. Organic components, we actually see a lot of your surgical prep and implants are now 3D printed based off an MRI. Even some of your shoes are out there, glasses. If you've had any dental work or know someone that has, most likely those are 3D printed, especially if they had it ready within the next day or two, totally 3D printed right in their office, off a 3D printer that costs about $2,000 or $3,000. Now, you don't get savings from that. They don't pass that along, but the fact is they're using the technology to make the better things. I often kind of like try to do this. This is not going to work as well, but I'll use it this way too. So for example, let's say 10 years ago, I went to a manufacturer and I asked them to produce this part. It's a fairly standard looking part, very kind of straight edge, you can see there. And I said, can you make, a bunch of these parts for me? They would say, yes, absolutely can. We'll just do some injection molding. There you go. And I say, well, that's awesome. But now we're in a little bit more of a world where sustainability matters. And so my next question is, could you make this part? It's roughly the same size. The holes are in the same location, but you will notice that I have added more holes to it to make it a little bit more sustainable, a little bit less wasted material. And they would say to me, you know what? Yes, we can make that part for you, but it's going to cost you. It's more complicated. And I'm like, okay. But now we're in the world of AI. And AI allows me to design what I refer to as the perfect solution. And you can see this part. And if you look closely, you can see once again, it looks like it's made out of bone. It looks very organic, very curved features all over the place. Still the same hole patterns, still the same function, but my AI software tells me that this is the ultimate solution. You will never make a better design than this. And if I go to the manufacturer and I say, can you make this for me? They will say, no, it's too complicated. Conventional technology can't make it. And then I would say, well, this is the best solution. This is the ultimate solution. It'll never get any better. And they would say, we just can't. It's too complicated. But the point is, our 3D printers will look at this part and be like, whatever. It can make it all day long. That is the point of this whole movement, is it's not about the printer itself. It's about the fact the printer can now make the ultimate solution. And so going forward on the screen, you can see some of the things that are made. And of course, the question is, why does this matter to Kentucky? Well, the same logic is there, is that we are a state that manufactures via aerospace. We have automotive, we have agriculture, but we actually make the majority of our export money on aerospace products. Now, we're not necessarily producing the planes, but we're producing the parts for the planes. So that's the key factor in all this. And the aerospace industry loves additive manufacturing. Back in 2013. And they asked the question, they said, this fuel nozzle that we use in our jet engines, about this big, it typically is made out of 20 parts assembled. I wonder if we could 3D print it. So the engineers go to work, they figure out they can 3D print it, and the results are on the screen. The 3D printed version is 25% lighter. It is 5 times more durable. And what used to be 20 parts is now reduced down to 1 part. That's a critical issue in all of this. And so they thought, well, wait a minute, this is amazing, tell us more. And they ran the rest of the numbers. On the left, the blue, you see is the conventional way of doing it. On the right to the green is the 3D printed version. On the right, you see weight is down. Manufacturing cost is down. Life cycle cost, meaning that it's more sustainable, is down. But then there was this other one on the far left. Suddenly they were like, well, wait a second, why are we saving so much on inventory? And the answer is quite simple. It's because they can now print on demand. And so eventually the CEOs and executives are like, so we don't have to pay for like insurance and storage and security and all the paperwork that goes with us having property and taxes and everything. And they're like, no, you can just print when you need it. And that just changed everything. So much so that they did it again. New turboprop engine, 855 parts down to 12 by 3D printing. 5% weight reduction, 20% reduced mission fuel burn. That's huge in aerospace. They did it even further. On the bottom, you see is a the way they used to do it, this particular part used to be combined of 300 parts, took 60 engineers to make it happen, 50 different manufacturers to contribute those 300 parts, and the number of places they could actually repair it was 5. 3D printed version, it takes one printer, 6 or 8 engineers, one manufacturing source, and they can repair it wherever the machine is. That's the key thing. And you all make the decision. On the left is the old way of doing it. On the right is the 3D printed version. You can easily look at this from a CEO perspective and say, well, that looks more like aerospace. The one on the left looks like it's something from the Nautilus from 20,000 Leagues Under the Sea. This is the way to go. And it's not just because of that part reduction. It's also because of the fact that they are printing from the inside out. They can make complexity internal. That's a huge deal. Now, the catch is, going back to this slide and thinking about it from Kentucky's perspective, what happened to those previous 50 manufacturers who had those contracts for those 300 parts? That's the key. Those contracts just went away because now they don't need it. Now they need someone who can 3D print it. So that's the genesis of everything that we started off doing back in 14 to develop the program, because this was the warning sign. This was the shot across the bow of, we have to have this technology in our workforce because it is changing everything. And from that, we started moving into all sorts of things. We looked at the fact that we're looking at these companies who are doing 3D printing in rural regions. Andrew is actually building a new facility in Ohio for defense. And we're talking about drones that are printed. We're talking about missiles and seafaring components that are part of the process. 3D printing technology is manufacturing them. And it's also the catch of, like, their argument is right now in terms of wartime manufacturing, if we were to go into a situation of wartime manufacturing, we would have only around 8 days in our current situation before we run out of certain munitions. And so their goal is to move into this space. So right now they're actually they're building this new campus up in Ohio specifically for scaling up in defense manufacturing. So as I mentioned, this was the move. And so from Somerset location and our 16 sites, we actually developed Kentucky's very first program. We got it on the books. It's called DPT 100, and we got it started in 2015. And through the process, we're doing all the normal things. We're looking at the biomedical applications, partnering with National Science Foundation, the USDA, to do the advanced design, get people moving in this direction, making all kinds of parts and products, and showing the technology off to folks so that we're both building the workforce and the industry at the same time, because it's such a new and fast-moving technology. Everything from your metal printing applications. We actually technically became the Additive Manufacturing Center for KCCS back in 2018. And then we try to connect every company that we meet with the application that additive can do for them. Because it's so broad, there's so many possibilities. It's really about just looking at the technology and figuring out, hey, what's a good fit for you and how can we benefit? Now, one of the reasons that we were set apart, because a lot of people have 3D printers in schools. Even sort of back then, there was several people that had 3D printers. And of course, now we've got 3D printers all over the place. But the problem we saw, and we still see today, is the fact that most of the 3D printers in your schools are being used to do this. Chains and trinkets. And that does not impress industry. Here you have this advanced technology that can literally be used to make aerospace parts and life-saving devices, can be used to save tens, if not hundreds of thousands of dollars, and it's being used to make a poop emoji. And that's the telling point here. And so what we did with our program is, yeah, we'll let them have like 1 or 2 lessons where they do some basic little fun things, but then we quickly move them into things that really, really matter. And we also realized was the secret sauce to getting this to scale, because it wouldn't do us any good if just Somerset was teaching this. This had to be a statewide initiative. This had to be a statewide push. And the secret sauce in making that happen were the teachers. Being able to actually connect to folks and teach them how to do 3D printing. So That is what we refer to as the Advanced Kentucky Model. Partnering up with the Kentucky Science and Technology Corporation and the Advanced Kentucky program, we were able to train teachers in the delivery of 3D printing coursework. And we learned a lot of lessons with this too. So for one, you can't just do a workshop with a teacher and expect that to take and actually be transformative. What we do is we actually take a teacher who's the additive champion, the person that we meet somewhere at a conference or in a recruiting event, and we find out that they just love additive, that they think that's the best thing ever. And it honestly doesn't even matter what their field is. Yeah, we'll have some folks from the CTE side, the technical side. We'll have math majors, we'll have science teachers, we've got biology teachers, we've got English teachers. Doesn't matter. What matters is they have the excitement for the technology. We take them and then we train them in how to deliver it over a course of 16 weeks. And then when they're ready, they go back to the classroom, or I guess technically they open up a new class the next semester, and we have the entire course, lessons, assignments, videos, education material ready to just plug and chug into their class. The teacher doesn't have to create any new curriculum. They essentially just have to grade papers and actually just help the students along. In fact, most of the time we're grading the papers because they're actually taking a college course with the students. And so that's the model that we found would work. And what you see on the map is all the sites that we have teachers now teaching our courses or have trained and are scaling up. To date, we have roughly, it's probably closer to 5,000, but when a little bit further back in how you look at it, we're somewhere between the 3,000 and 5,000 students that have completed our DPT 100 course. We've trained roughly around 250 teachers. We're in over 100 schools across the Bluegrass. And then in general, just in terms of exposure, we're probably somewhere between 5,000 and 10,000 students across the state who've just at least been exposed to it. Maybe not having taken a course, but have actually been trained at the K-12 level to some degree. And we're having them produce things like this, parts that look like they're drone parts. One of their capstone projects is they have to literally 3D print a jet engine. Now it's a plastic version and it's printable off one of those $400 printers, but you can see the complexity here. Bearings, screws, nuts, 3D printed parts, and it moves. Like you can see the turbines, you can see the movement, you can see where the compression zones happen to actually compress the gas and create that tremendous amount of thrust. This is what we have them make. Now, in certain cases, we take them on to other courses or other levels where we teach them how to 3D print it, even actually how to weld those metal parts together. And by the way, surprisingly, 3D printed parts weld exceptionally well, surprisingly well compared to conventional. We even show them how to do certain ways of testing, how to validate parts, how to figure out if what they just printed is a good design or a bad design, and how to move things along. One of the other things that you have to really understand, this is one of the sort of the blocks that we saw when we started teaching students, is that even though here was this advanced technology, they did have a tendency to design very squarish things. And it's not just because of Minecraft either. It's just like that's the natural tendency. It's nice straight lines. It's easy to design. And yet what you see on the screen, these are the ultimate designs. Parts that are made from the inside out, almost like you have a seed of the perfect part, perfect solution, and it grows it from the inside out. The middle one, for example, what you're seeing is a cutaway view of inside the part, where that 3D printed complexity allows for a high differential and surface area for heat exchange. The one to the middle right there, that tube system, that's a completely different shaping of airflow that we could never do conventionally, but yet it's printed in one shot. Even the one on the right is the heat exchanger that has phenomenal performance, and you literally cannot make it any other way than 3D printed. So this is why aerospace loves it. It is also why automotive is getting into it. And so our students are creating things like this. This is what they're doing. We teach them if, they have the opportunity, they can actually go make body parts for people. And what you're seeing at the top there is just a 3D printed hand. using simple wires and rubber bands and screws to actually make it grippable with certain motions. And then, of course, the leg on the right, that's 3D printed. Super customization is even possible. We've actually seen amputees that have 3D printed appendages, and they will customize their appendages with 3D printing technology. Seen everything from flashlights to Wolverine claws on them, just for fun. And the technology is growing too, because now not only have we entered into the age of AI where it's designing better parts, AI also is opening up new doors for us where we have the ability to use text to describe a part. So what you're seeing here is an example of a software called text to CAD. You know, there's several different variations of this type of technology out there, so this is not the only one. And a lot of companies are figuring out what is the best way to do this. But what you see is they're just typing out and describing the part that they're after, and it's creating the 3D model that is then 3D printable. Meaning that you don't have to learn design software, SolidWorks, Fusion, AutoCAD. You can just quite directly type out what you're interested in, and the software will make the model for you, and the 3D printer will print the object. So not only is the technology versatile and now accessible, now it's also even more accessible because people can learn to do it with a simple few clicks of a button. Really learning how to talk to the software, talk to AI is more of the critical challenge now. So it's not like we're talking about the labs of the future and the manufacturing facilities of the future. We absolutely are. The only difference is we're talking about them right now because it already exists. We've had it for years. In fact, we've been using AI to generate some of those, a part like this ultimate solution. We've been doing that since 2017. So the technology is already there. The use of it and the innovation through it is what we're after. And so that's why this is such a big deal. When you can actually just type out what you want, this makes it possible for everyone to use it. And that's what we're always after. Now, of course, I'd be remiss if I didn't talk about the next big initiative. So what you've seen so far is what we're already doing. We already have 3D printing in these courses, in these high schools, in these community colleges. And in fact, now we're actually spreading to other states. Our program, we're potentially working on it. We've already got some teachers now in Ohio that are doing it. We're working on the Midwest, and we just got a request from Hawaii to start sending our courses to across the Pacific. So that's where we are. But the next thing, the thing that's happening right now and actually coming up this month is, of course, the concrete 3D printing. Same kind of concept. We can 3D print structures that are the ultimate solutions. And so you probably have seen videos on YouTube, but you can 3D print a house. You can 3D print a building. It's just a bigger printer, and it's still using concrete. So it just uses concrete, lays it down one little layer at a time, and builds it up. To give you a sense of scale, the printer that we're using for early tests is what you see behind us there on the picture. Stands about 16 feet tall. You can print about a 30 by 30 volume, and it's a big old monster. But it's been a great learning experience. We do a lot of testing, a lot of you can see some of our really scientifically special techniques there of evaluating things. Got a lot of video, and we're using that to figure out what is the best use of the printer, what's the best shape for the printer to produce, and what can we use the printer to create that is a next level way of building homes. So going through the process, figuring out what works, what doesn't work, testing different sizes and shapes. We had a lot of great partners in this process who've come alongside us to make all this happen. And you can see, it looks fairly basic in concept. Testing out like when is too much concrete? When do we not need that much? And most importantly, now that we have the data, where do we need material and where do we not? So what you're looking at is a finite element analysis, one of our softwares that we use to analyze structural loads on a building to see where the stress is. That way we can decide where we need material and where we don't. So what you're seeing there is actually the blue. The blue represents where we have more strength than we need, safety factors of like 10 or 12. I mean, it's 10 times stronger than it needs to be. When you see the yellows and greens and the reds, that's where you're like, you know what, this is where the force is going to be the worst, so we're going to thicken it up right there. And using that to create this. We call this the flood buster. And so what you're seeing is a floor plan, a house plan that's designed and technically was the mission of the USDA and the Appalachian Regional Commission to solve some of the problems that we were dealing with. We've seen the floods, obviously now we've seen the tornadoes, and USDA gave us the purpose of using concrete printing to stop it. And so what you're seeing, if you look at the corners of this design, you're seeing these arched shapes of those corners with that reinforcement, and then the walls taper back down. This is the power of 3D printing, because I can tell you exactly the amount of force we need to withstand from a class 4 flood or an F4 tornado. And we've used our software to reinforce this thing to the point it can take the hit. And it's concrete. So even if it does flood, you can go in, you can Clorox it back out, and you can move back in. Doesn't have the mold issues. It'll still be standing there. You have the ability to do what we've never done before. And the residents, the homeowners, they'll never know. They'll never see those curves from the inside to the outside. They'll just see curves. They won't know what's really there, that this is literally a bunker disguised as a pretty house. That is the power of the technology. And the printer will do it for us day in and day out. It has no issues with that at all. Now, just to show that this is not theoretical, take Walmart, for example. What you're looking at is a new edition. Walmart just had done about 2 months ago. It is a 5,000 square foot edition. What you're seeing there are 20-foot walls that are being 3D printed by a crew of about 5 or 7 people. And it's concrete, it's robots, it's automation, it's everything we want manufacturing to be. And it's making a structure. So the overall stats, as I said, 5,000 square feet, 20-foot tall walls, but here's the kicker. It was done in 7 days. That is unheard of in the construction industry. If you go into a Walmart, you're going to look around and you're going to see that the walls are typically concrete block. And to go up 12 feet, you have to put up so much scaffolding and safety measures and all kinds of things that the 3D printer doesn't have to do. So even the general contractors that are on this project, they're like, we couldn't touch this if we've tried. There's no way we can compete with this kind of speed and effectiveness and strength overall. And here's the telling thing. This is what really gets the attention. They have 12 more sites planned for this year alone. And not only that, they're also doing it with Amazon too. That's the telling mark for this. This is where everything's going. And so with that sort of in mind, you know, what we're going to be doing with the technology is that we will be printing Kentucky's first 3D printed home. We'll actually be doing it right here in Somerset. We call it the Floodbuster 1. And you're seeing like a preliminary design. We have a slightly different floor plan now that we've done some analysis on it. But it's going to be about 800 square feet. It's going to have a little porch on it. And it's going to be a home that we're partnering with Habitat for Humanity as a demo, so they can turn around and start doing more of them following this. And this is also a design that will be printed in Texas and Chicago, so they can take it and start taking it through combustion testing. It doesn't burn, obviously, but it will protect you from fire from the outside. They've done one preliminary test. And so essentially, again, since it doesn't burn, what they've been doing has been piling up wood and stuff on the outside walls and lighting that on fire. So outside surface temperature is about 1,400 degrees Fahrenheit. Inside surface temperature, inside the wall, inside the house, was about 65 or 70. And it's the power of this technology to do this. And so, yes, so this Floodbuster 1, our next step, doing it right here in Kentucky, first time ever. And it will be setting the new standard for construction. And really what's making it possible is not the technology itself. We've had it for years. It's the fact that it's been miniaturized. So what you're looking at is some of the technology we will be using over the next several months, not only to just to print houses, but to print other things too. It's mobile now. It's a robotic arm. A lot easier to get in sight than that big, system that I showed you earlier. And it's fast. That's the key. Speed is greatly increased. And we can literally drive it up a hill. That's the point of this. But it's not just buildings. The other thing about this technology, this concrete 3D printing, is you're not limited to just buildings. Think about all the other products that we have in our world that are concrete. Think about all the things that we take for granted every single day that are generally made by pouring huge amounts of concrete into a form, breaking that form apart, and then trying to ship it somewhere. Think about all the culverts that we have everywhere. Eastern Kentucky, Western Kentucky, storm control. They're all over the place. But think about our ability now to make a new design that actually can be shaped for the environment. Because right now, if you have like a subdivision you're putting together, you have to go order culverts and manholes and infrastructure based on what a catalog has, and it's going to be shipped to you. With a 3D printer, you can design the ultimate solution for where you are and how it needs to be, and the printer will just make it on site. So that is the unsung hero about this whole evolution, is that we can go from what you see on the right to what you see on the left, which actually has better flow control, has better soil stabilization, is actually lower cost to produce, and you don't even have to transport it. You just print it right there. And so that's also going to be the industry that Kentucky will have the opportunity to take advantage of, is the concrete industry in itself. Because this machine that can print a house can also be a micro concrete factory. You can have it set up 24/7 just printing products. And that's going to open the door for a huge opportunity, economically speaking, for Kentucky. It's multi-billion-dollar industry that we can start getting pieces of by moving into the technology. So homes, structure, everything. Now, overall, I do want to give us some time to kind of like have some questions. We have worked on multiple ways to integrate additive manufacturing into the businesses. One is what we call the risk time reduction model, where companies can work with us to explore additive, and we show them how to use it and benefit their business, form that public-private partnership. Things maybe on the military side, getting into defense contracts. We work with folks all over the nation, even partnering up with our R1s like UK and Louisville to do the testing and validation of certain parts. Putting these deals together, putting the partnerships together so that we can do projects together, work to set up these AM labs, work to help companies integrate the technology and get going, and then even share profits in that process. Because there's roughly around 3,000 manufacturers that are even associated with Kentucky Association of Manufacturers, and they're all over the map. And yet every one of them can use the technology in some way. Let me give you an example. American Woodmark's a company that's just a few miles down from Somerset, and they bought this single printer. At the time, it was about $2,000. And they used that printer to make some adapters for some of their equipment. Won't go into the details of the equipment. We do have a case study upon request if you want to see it. But they use this printer. I think they got two, or maybe that plus a little bit more, because I think their original investment was $3,500. But because of that printer, they are now saving $160,000 every year off that single printer purchase. And the reason they're saving it is the part they're producing is not that complicated, but it's the fact that it used to cost them $800, and now it costs them like maybe $20 to make. But they can produce so many of them, and they've actually enhanced the design such to a point the part never fails anymore. And so it's part of their regular maintenance. Whenever they do machine changes and those kind of things, they just have this printed part and no longer have the downtime. And that's where the power of the savings really kicks in. So, and not only do we do kind of like these projects where we help companies integrate additive, we also, of course, do workforce training, teaching students, doing customized courses, showing them how to use additive overall, how to work with it, how to weld it together, and develop it out. And part of what we do is also just make people aware of what's going on. So I do want to take a moment just to kind of like stop for a second. If you want to, you can screen capture or whatever you need to do. These are some of our social media platforms that we share a lot of the stuff that we do and just make people aware. But before I continue, I have a few more slides and one more big announcement. I did want to stop though and say, does anybody have any questions they want to ask about the technology? We can take a few questions now. I'll take a few more questions at the end. I always
So
try to go for overwhelming.
no doubt. So while folks are getting their questions together, and I may be asking a question that's outside of my understanding of contracting, but the layers of concrete that are, you know, spit out by the computer, how do they need time to dry before the new layers are put on, or how does that work?
There is a timing ratio. You don't want to do too many layers before you have like a failure point. What you a couple ways: one, to a different wall, back to it, and keep that time separation. The other thing is we actually, and we do this in regular concrete all the time, we add accelerants. So you increase or you reduce the curing time by adding in a little special mixture to the mix. And so what normally take a cure takes like 15 minutes to cure to it. So that's all in the we just figure out exactly what we need and plan our design out so that it's all built into the process.
Thank you. I think we've got a couple other questions. Ryan, I saw you come off mute.
No, that was my mistake. I didn't mean to come off mute. I apologize. I joined late, so I apologize.
That's okay. You've got a question in the chat. How many school districts are working with you? Any in Fayette, Scott, Woodford, or Jessamine counties at this point?
Yes, actually. So I think we have David Lane is one of our Fayette folks. I think there's about one or two others so that we have trained. So we have several teachers in those regions. Which particular schools I can't say that I keep track of. I can easily get you in touch with Sherry at Advanced Kentucky, and they can tell you where they are specifically. But we definitely have folks in Fayette area and just Jefferson as well. So a lot of folks, and like I said, it's about finding those. And once we find those folks, give them all they need to do the classes and help the students and grow the programs. I think David, for example, he actually teaches 3 courses now in this technology.
And I know you're going to give another chance for questions. I noticed there are a couple of employers on, and I'm wondering if they have any questions. You know, if you all are using this innovation right now, or if you can see some return on investment. You know, he's given you details on some of those return on investments that have been seen. So just a shout out to our employers and if you've got any comments.
We'll go ahead and just proceed on and see what we find out at the end. So, you know, it is all about doing work together. And so what we talk to folks is about in terms of next steps. What would the next step be? Let's say you do find this very fascinating, or you're interested in your business getting this, or you just honestly want your community to be accelerated in that space. You know, there's several ways we can do this. From a business standpoint, obviously we can do an additive manufacturing project with you. We can actually come and figure out what your business model is, what you need it to be, and show you how to produce what you need, whether it be actually like parts that are used for learning purposes, training purposes, or, you know, very commonly on the right, it's a tool or fixture that is just used for quality control, or even tooling itself. There are actually companies that are 3D printing tools to make products. So doing an additive manufacturing 3D printing project with you is absolutely on the table and could be a next step. The other option, though, is to simply get trained. Whether that means that you're actually taking an employee and actually putting them through our typical college courses, or requesting customized training. So we have a lot of companies that say, you know what, we want to get into additive. We don't want to do a full college course. We want to just hit, this, and this, and we want to do it over a week's time. Totally fine. We also have companies that say, you know what, we want some freedom. We want to do a little bit of remote training, and then we want to dial in workshop at the end. Totally fine too. So our ability to actually do customized workforce training specifically for additive, coming from the experts, and Eldon, for example, actually is probably one of the top technicians, and one of the earliest technicians in the technology, and working with one of the biggest 3D printing companies that took off in the market. So we can give you the exact technology that you need and training and how to use it for your purposes. So that's always the thing. And that's why we built our online cloud-based system, is that it allows us to teach online, teach remotely, the basics and the design, and then do the dial-in for the hardware. Because what we'll say time and time again is 3D printing is not about the 3D printer. It's about what the 3D printer, the shape of the 3D printer can make. Now, there is another way, another next step option, and that is one of the things that we always need or encourage people to do is sponsor a teacher. The fact is, it does require, was funding all of these advanced Kentucky teachers that we were training, and it's something that has been very effective, but those grants ran out. So now we're just looking to communities and say, if you want this in your community, just sponsor a teacher. The teacher can come to us, we teach them in the class, get their first printer taken care of, and then release them out with the new content for them to offer the courses. So that is always an option. And that makes a huge impact on your community, because that teacher, once they go through that class, they're impacting 15, 20, 30 students every semester. And that is putting additive mentality, 3D printing logic into your community, every student that comes out. And we literally train the students in how to use additive on the job, not just because it's their only job. They might be welders plus 3D printers. They might be dental technicians plus 3D printing. They may be, culinary plus 3D printing. But it embeds that knowledge and logic, so they bring those innovations with them. So sponsoring a teacher brings it to the community, brings it to the businesses. And the overall goal is that one day our students are going to be the ones who are doing this, who are printing these houses, who are making these new creations that no one's ever seen before, who are, and quite literally printing aircraft parts and developing the next generation technologies. It's because of the access to these printers and this knowledge that makes it possible, printing surgical tools, body parts, and getting things going to that next level. So again, we can do a project with you, we can train you in AM, or you can sponsor a teacher. I'll kind of let you think about this before we wrap it up. What you're seeing is a new type of jet engine thruster that could not exist if it wasn't for 3D printing. It is like a huge leap in technology. It's even called the LEAP engine, LEAP 71, specifically because its performance is just phenomenal compared to conventional. And as you can see, 3D printed. 3D printing can do stuff like this. That's what's making it possible for us to take advantage of physics and science and chemistry that we've never been able to before. And to kind of close out, and this is actually, you all the first ones in the public to see this. This will go out later this afternoon, maybe tonight. But we are now opening up the invitation for everyone to come see Kentucky's first 3D printed house to be done in live action, if you will. So on June 27th, we're opening to the public at 10:30. We'll keep it open till about 3 o'clock, and we'll be producing that Floodbuster 1 home right on our site. And this will be the first time it's ever happened in Kentucky. Many states, there are some states doing it as well, but there's many states that haven't. So this is going to put us not only on the map, but it's also the first one ever to be done specifically for affordable housing, but also affordable housing designed to take the hit of a flood and actually to use the Floodbuster design as part of the work. So this is an invitation to everyone. You could definitely see the invitation on our social media later on, but we welcome all of you all to attend and see this for yourself. Come ask questions. We'll, of course, do press releases that go with it. but it's going to be a phenomenal event. One of the cool things that it's going to be is it's going to involve one of the largest 3D printers in the world. It's the same printer that was being used to print some of those Walmarts and will be on its way to print an Amazon building after it leaves our site. So it's going to be a pretty phenomenal experience. So you're all welcome. And I did share the flyer with Debbie to actually pass out as well. So just to kind of wrap it up, that is our social media platform. That's kind of what we do. And that's a little story about 3D printing. What questions can I answer now?
Steve asked a question in the chat, and I think you answered it predominantly, but just wanted to make sure. Is this a degree diploma pathway? And what's the scaling right now with other KCTCS campuses?
So what we did is we started off with certificates because most companies don't want someone who has like an associate diploma in 3D printing. They want a skill plus 3D printing. So what we did is we created a 16 credit certificate in additive manufacturing. We are also about to roll out a 2-course certificate in manufacturing specifically for design. And so what students can do is they can actually take the first class, get the basics, take the second class, get the advanced AI design components, take the third class, get a lot of that hands-on experience that really helps them dial in, do testing, but you can stop and start at any point. And we do have some associate degrees developed, depending on if the companies just are like, this is what we want, or students just want an associate degree in this kind of technical field, totally viable too. So we have all levels. Most folks typically go with the certificate route though, because that doesn't require them to add on a lot of courses. It allows them to get their primary degree plus additive skills and have a certificate to show for it. Now, one of the cool things though is that that 2-course rolling out, that could actually be completed in high school. So all of those teachers that you saw across the state that are at their sites, we can start offering those certificates at their locations and getting that skill set into them, get them credentialed before they even leave high school. And of course, like I said, this is actually offered statewide, and we can route it through any of our sister colleges, or if it's not in a region at Somerset, we can offer it directly ourselves.
Well, we can't thank you enough for this presentation. And I know it started off, at least this year, started off down in the Cumberlands, and a big shout out to Myra for lifting up the opportunity for us to scale this statewide and beyond, right? This is definitely the future. So, and I think one of the biggest takeaways isn't just the printers, like you mentioned, it's the collaboration. So you all make sure that you're sharing back best practices and making sure that you're staying plugged into your educational partners, your local workforce development areas, and all of your partners to see what great things are happening out there. But Eric and Eldon, thank you both. I know Emily is on here as well, so we can't thank KCTCS enough for just jumping into this, seeing this as a viable pathway and really offering this. It does sound like the sky's the limit. Maybe a concrete stairway to the sky. I don't know. The Tower of Babel all over, right? But we've got some great things that can happen from this. So,
Debbie, one more quick question.
yeah.
How long does it take to complete the CDL printing courses?
So basically they operate about a class a semester because you have to build. So the very base level certificate, that 2-course, will take you 2 semesters because you have to complete them. Unless we do it like on a bi-term, you might be able to get it done in 1 semester. Most will do it 16 weeks for the first class, 16 weeks for the second class, and you got that. For the 16 credit one, we're able to stack them decently. That takes about 3 semesters.
Okay, so about a year and a half.
About a year and a half at most. Some people can get it done in 2. The smaller certificate for sure can be done in 2.
Okay. Great,
Or
thank
2
you.
semesters, 1 year, I should say. Sorry.
And then we know there's a cost associated with most things in that year and a half that it takes. What's the estimated cost to sponsor a teacher?
Sure. So the teachers basically are just paying the tuition for the course and doing a dial-in workshop, and we make sure they have a 3D printer to go with it. So I think roughly the cost is around, and give or take a little bit on terms of where the printer costs are, it's about 1,400 a teacher for their training. And then once that's handled, they're in the field. We are delivering the courses as a college. And so their students are actually getting college credit as they deliver that course.
Wonderful. I know a lot of folks are thinking about next steps with this. So again, Eric, Eldon, Emily, thank you all for your time and your presentation today. You all have information. We will be sending out that link again for the end of June actual printing, 3D printing of the house. So stay tuned for that. And other than that, everybody have a great day.
Thank you all so much.
Take care.